We are going to look at some primary cells, electrical cells that we use in the lab. You will come across two names, primary electrical cell and secondary electrical cell. The name comes up. In a primary cell, the chemical reaction inside the cell is directly converted into making a potential difference at 2 points, which we call electrodes. In a secondary cell, you need to use electrical energy first, cause a chemical reaction and store that electrical energy in a way that a potential difference is created by the chemical action. They are also called storage batteries. Such types are used in vehicles. Now, when you talk about a primary cell, it is a chemical action which causes the potential difference to be set up. The simplest cell is the simple voltaic cell. In this cell, you have a glass jar, and in the glass jar you pour some sulfuric acid. I have already put some in it. You need just two dissimilar metals. In our case, we have taken zinc and copper. To distinguish the two, one is a rod and the other a plate. Activation series from your chemistry will suggest and tell you that one of them reacts more with sulfuric acid. As you put these inside this glass jar, a chemical reaction at the zinc electrode can be seen and the copper electrode is formed like this. If you were to measure the potential difference across these two terminals using a voltmeter, you can easily get its value. Say I connect this negative to the zinc rod and my copper plate, you can see your voltmeter reading is about 0.8 volts. Let us now understand what reaction is taking place inside this simple cell, which is creating a potential difference between the two electrodes. We have our glass jar, dilute sulfuric acid, the zinc and the copper. Let us start what is happening inside the dilute sulfuric acid. You have the hydrogen ion and the sulphate ion. It is dilute, so plenty of these charge carriers are available there. Zinc reacts more than copper from the activation series and it would dissolve or tend to dissolve into this setup. That means, leaving behind 2 electrons, zinc would enter the solution, combine with sulphate ion to make ZnSO4. The outcoming zinc positive ion is going to repel the hydrogen ion towards the copper plate. At the copper plate, the 2 electrons are drawn out from it and the hydrogen and the electrons combine to set out the hydrogen bubble, and this is going to leave the copper positive. So, the copper plate becomes positive and the zinc plate becomes negative, and we can see this is a very simple straightforward reaction inside this glass jar, creating a potential difference between these two. So, if you connect this with a voltmeter here, the potential difference across these two terminals is what we measured by the voltmeter. If you put some bulb in this circuit, that should glow, and that is how this first came about as a simple cell. There are other modifications and other simple cells which are used, because this has flaws. And what are the two main flaws? One is that there is polarization. Polarization is the name given to, because this plate is becoming positive, more hydrogen cannot come in here, because this is going to be repelled by it, and therefore, there is a collection of bubbles onto this plate. On this one, I will show you again. See here, the reaction is taking place at the zinc plate. The zinc plate is going to become thinner and thinner as this proceeds, and the hydrogen bubbles are going to collect, or hydrogen ion and bubble are going to collect around the copper plate, and this is called polarization because it does not allow any more to come in. So, if you want a steady current from it, you would need to take this plate out, wipe it clean and put it right back. The second fault that is there is called local action. The zinc rod may be full of impurities and local cells may form. This means instead of getting the correct potential difference between the two electrodes, you may not get so. So, what is done is that you galvanize this zinc rod, amalgamation is done, so that the zinc is the only thing that is in contact with sulfuric acid. A simple voltaic cell is not so useful in the lab, it does not give a constant current. So, there are other variations which are used in the lab, which you will use in your experiments. One of them is designed by Leclanche. It contains a glass jar. Instead of sulfuric acid, you now have ammonium chloride solution in it, some of which I have already put. There is a porous pot, and this porous pot has MnO2 and carbon. At the center of it is a carbon rod. This is placed inside the ammonium chloride. There is a zinc rod which is placed on the outside of the porous pot like this, and this becomes a cell, and this cell is called a Leclanche cell, and we will measure its potential difference. I take one of the electrodes, connect it with the wire here, use my crocodile clip, and the other one to the other terminal. It gives a voltage of about 1.4 to 1.5 volts. The advantage of this cell is that it does not have an acid, there is no polarization, there is no collection anywhere. The MnO2 acts as a depolarizer, the carbon inside it is a conductor, and you get a fairly good sustainable potential difference between the carbon rod and the zinc rod. Remember, the carbon rod becomes positive and the zinc rod becomes negative. There is yet another cell which is commonly used in the lab, and that is a Daniell cell. In a Daniell cell, you have a copper pot, and in this copper pot, you fill copper sulphate solution and concentrated copper sulphate solution. If you look carefully, the pot has a little bracket around, and you can put on it some granules of copper sulphate, so that it has a high concentration of copper sulphate. There is a porous pot, again for the same reason that you will have to cross over the hydrogen ion such that there is no collection anywhere. Inside this porous pot, you add your dilute sulfuric acid, and of course, the zinc rod acts as one of the electrodes. You might be wondering, where is the other electrode? If this is going to form one electrode, where is the other one? Well, the copper pot itself acts as the electrode. There is a terminal placed here, which is there to get the potential difference between the zinc and the copper pot. The reaction in this case starts from the center of the cell. As I put this zinc rod inside it, the reaction between sulfuric acid, as we had just seen, starts here. The hydrogen ion goes past the porous pot onto the copper sulphate, and the copper is deposited on the inside of the copper pot. We can measure the potential difference here using our voltmeter. I connect this to the negative terminal, because here again the zinc becomes the negative terminal, acquires negative potential as compared to the copper pot. The potential difference between the positive copper electrode and the zinc electrode which is negative is 0.9 volts. We have seen two primary cells which are little better than the simple original voltaic cell, and what is important here is that these cells when in use offer a lot of internal resistance. Ions are involved. So, there would be resistance by the electrolyte. There are other reasons also because of which the cells acquire a certain resistance from inside. They do not maintain a constant potential difference. However, because a chemical reaction is able to produce a potential difference across 2 points within the cell, they have immense importance in understanding how a chemical reaction can create electrical energy. So, you have learnt the simple voltaic cell, the Leclanche cell and the Daniell cell. You have studied its composition, you know why they get 2 points within the setup, one positive and the other negative. There is a potential difference which we measured by our voltmeter, and we have seen and studied this today.